Welcome back to the Deep Dive. We're here again, taking that sometimes confusing pile of information on a subject and try to boil it down for you.
That's the plan.
And today, we're zeroing in on something pretty crucial in craftsmanship. Maybe the most crucial thing: precision. What really makes the difference between those amazing heirloom pieces and the kind of wobbly, frustrating projects we've all probably made.
Yeah, we've all been there.
It's not just about raw skill, is it? It's mastering measurement and marking.
Absolutely. It really boils down to consistency, like at the micro level. And for us here in North America, well, it gets complicated, right?
But the two systems.
Exactly. You're constantly juggling imperial, fractions, feet, inches. And then you've got the metric system, which is so streamlined, logical.
Yeah.
And that difference, that duality, it trips a lot of beginners up, creates a sort of mental block. But maybe more importantly, it's where calculation errors creep in.
Little errors that just add up.
They multiply across a project, yeah.
Okay, so that's the challenge we're tackling today. We've gone through the sources, and we think we found a clear path to getting that uncompromising accuracy.
Right.
Doesn't matter which system you prefer.
Right.
Our mission, really, is to cut through all that noise, give you just the essential stuff you need for both measuring systems, and this is key, show you the pro marking techniques.
Because measuring is only half the battle.
Exactly. So
Yeah.
by the end of this, the idea is you'll feel, way more confident approaching any cut, any joint, like unshakably confident.
Okay, let's start with the basics then. The system most of us start with, Imperial.
The tape measure.
Yeah, the tape measure. Probably the most used tool in any shop, right? But it's not just about finding the inch mark. It's about understanding what level of accuracy you actually need.
Right. We don't need a whole lesson on reading a ruler line by line. I think the big takeaway here is the target. For most fine woodworking, you got to consistently hit that 16th inch mark.
116th.
Yeah, 116th of an inch. That seems to be the gold standard, the thing that ensures your joinery is going to be tight.
If you're hitting 116th consistently, you're doing professional level work. Simple as that. But the fractions themselves, they're tricky. Not just reading them, but adding them up, especially on the fly. You're trying to figure out, say, 11/16 plus 38.
Yeah, mental gymnastics.
That calculation strain, that's where mistakes happen. Big time.
And speaking of mistakes, the ones that get every beginner, and honestly, they still get experienced folks sometimes.
Oh, I know where you're going with this.
That massive difference between nominal size and actual size for lumber.
The invisible enemy. It's huge. Why isn't a 2x4 actually 2 inches by 4 inches?
Yeah, why?
Because, after it's milled, kiln dried, plain smooth, the final dimension, the actual size you work with, it's much closer to 1.5 inches by 3.5 inches.
Which is a huge difference if you're planning something out.
Massive.
Yeah.
If you build your frame thinking you've got a full 2 inches there, your whole project ends up, half an inch too long? It's sloppy.
That's an expensive lesson to learn on some nice hardwood.
Tell me about it. And that leads to why 3/4 of an inch week. You have to engineer the fit. You can't just force it.
Okay, so Imperial has its pitfalls, especially with fractions and that nominal size trap. Let's switch gears. Go global. Let's talk metric.
Ah, yes.
For anyone who's ever wrestled with adding 716ths and 58ths, metric really does feel like, this triumph of logic.
It really is elegantly simple. It's all base 10.
10 millimeters in a centimeter.
100 centimeters in a meter. Done. By designing it all around units of 10, you basically eliminate complex fraction math completely.
Or just adding whole numbers.
Or subtracting them, yeah.
Yeah.
Much easier.
And what I found really interesting digging into this was the professional preference. We might think centimeters, but most serious plants, especially the international ones,
they jump straight to millimeters.
They use millimeters.
Yeah.
Why not centimeters? It seems kind of fiddly at first.
It might seem that way, but it's actually about maximum precision and reducing cognitive load, like thinking effort. The aha moment for a lot of woodworkers coming from Imperial is realizing if you just use millimeters for everything, you're only dealing with whole numbers, always.
Ah, right. No decimals needed within the unit itself.
Exactly. You're not thinking 17.5 centimeters, you're thinking 175 millimeters. It completely removes that major source of calculation. Errors, the fractions, the decimals.
So you can focus your brain power elsewhere.
Right. On the joinery design, wood selection, the actual craft, not on adding fractions in your head.
Streamlining the thought process.
Yeah.
Okay, makes sense. Now, if you do have to work between systems, maybe you bought a cool template from Europe or something.
Happens all the time.
Our sources basically say, look, Don't try to memorize a giant conversion chart. You really only need 2 key numbers.
That's pretty much it. The absolutely critical one, 1 inch equals 25.4 millimeters. Gotta know that one.
25.4.
Got it. The second one, maybe slightly less common day to day, but still useful. Okay. 1 foot equals 30.48 centimeters.
Okay, 30.48 centimeters for a foot. So those two, maybe a calculator app on your phone.
And you're pretty much set for global measurement literacy.
Yeah.
But honestly, even better than an app.
What's that?
The tool that just has both. The global companion, as you called it earlier.
Ah, the dual scale tape measure.
Exactly. It's kind of fascinating how useful they are. Having both Imperial and Metric right there on the same blade, it just makes things obvious.
You can see immediately, okay, 34 of an inch.
Yeah.
Is that closer to 19 millimeter or?
Right. Is it pretty much 19 millimeter or do I need to adjust slightly for 18 or 20? It cuts out a whole conversion step right there on the tool.
Very practical. Okay, so let's say we've nailed the measurement. We're down to the 116th or the nearest millimeter. Perfect.
Feels good.
But that perfect measurement, it's totally useless if you can't transfer it accurately onto the wood itself.
This is the crucial next step.
We're moving beyond just measuring now. We're getting into the art, really, of marking. And this is where the pros really shine.
And it starts with ditching the standard pencil, or at least being very careful with it.
Why is that? Seems basic.
Well, think about it. A typical carpenter's pencil line, it can easily be 132nd of an inch wide, maybe more.
Okay.
So if you try to cut right down the middle of that thick line, you've already lost half your accuracy right there. Half your 116th is gone.
Ah, okay. The line itself introduces error.
Exactly.
Oh.
So specialized marking tools, they exist to solve that exact problem.
Let's break down the key ones, starting with maybe the most common step up. The combination square. People use it for 90 degrees, right?
They do, but it's way more versatile than just a 90-degree check. Its real power is in repeatability.
How so?
You lock down that adjustable head at a specific distance, say. You want a line 38ths of an inch in from the edge. You lock it, and then you can quickly scribe that exact same distance again and again, perfectly parallel to the edge.
Ah, for setting shoulder lines on tenons or marking dados.
Precisely. It's fast, it's reliable, and that thin steel ruler edge gives you a much finer line than eyeballing with a pencil.
Okay, so that's a good step. Then you get into the really specialized stuff, like a marking gauge.
Right. The marking gauge is designed specifically to scribe a super thin line, perfectly parallel to an edge. But it's not just drawing a line.
What else does it do?
It usually has a sharp pin or sometimes a little cutting wheel. It actually cuts or severs the wood fibers slightly along that line. Because it's a cut, not just a pencil mark, it creates a tiny physical groove. And that groove is a much better guide for placing a chisel or starting a saw cut accurately.
Interesting. So if the gauge is good, the marking knife must be even better, right? What's the difference there? When do you use a knife versus a gauge?
Good question. The marking knife is for when you need the absolute highest precision. The key difference is that knife line, it's generally deeper and it is truly zero width.
Zero width.
Yeah, think about it. A knife edge has no real thickness at the very tip. So it scores a line that is just a line, a boundary.
Yeah.
This is critical for a couple of reasons. First, like the gauge, but even more so, it gives your tool your chisel or saw a physical registration point. There's nowhere for the tool to wander. It slots right into that knife line.
I locks it in.
Exactly. And second, and this is huge for really fine joinery like dovetails, that scored line prevents tear out.
Oh, that fuzzy edge you sometimes get.
Precisely. When you put your chisel right into that knife line to pare away waste, the fibers on the show side are already cleanly severed, so you get a perfect razor-sharp shoulder on your joint. No fuzz.
Wow. Okay, so the marking knife is kind of the ultimate for hand tool joinery.
It really is your best friend for that kind of work.
That's brilliant. It's like a tiny zero-tolerance fence built right into the wood. Yeah, okay. And what about bigger stuff like breaking down sheets of plywood or big panels?
Yeah, for large-scale work, you still need the trusty old carpenter's square. Or a framing square.
Size matters there.
Absolutely. For squaring up large assemblies or marking lines across wide sheet goods, you need that longer reference edge. A small combo square just isn't practical. You'd introduce error trying to expend the line. So big square for big jobs. Still essential.
Okay. Perfect measurement. Check. Perfect marking. Check. Now, the moment of truth. Making the cut. Everyone knows the old saying, right? Measure twice, cut once.
The golden rule.
But the pro difference, based on our sources, isn't just measuring twice. It's knowing exactly how to approach that perfectly marked line when you make the cut. We got to talk about the kerf.
Yes. The kerf. Such a simple concept, but so critical. It raises that basic question. When your saw cuts, what happens to the wood in the cut?
It turns into sawdust. It disappears.
Exactly. That removed material, the width of the actual cut itself, that's the kerf. And it varies, right? A thin Japanese handsaw might have a tiny kerf, maybe 132nd of an inch.
Okay.
A standard table saw blade. That might be removing a full 1/18 of an inch of material with every pass.
That's a significant amount when you're aiming for 116th accuracy.
It's hugely significant. And here's the trap, the classic beginner mistake. If you line up your saw blade to cut directly down the middle of your marking line,
What happens?
you introduce a permanent error into your workpiece. Think about it.
Right.
If your piece needs to be exactly 10 inches long and you split the line with an 1/18th inch kerf blade,
Half the kerf comes off the good piece.
and half comes off the waist side, your good piece is now short by half the kerf width, so 116th of an inch too short in that case.
Every single time.
Every single time. The rule has to be always cut on the waist side of your line, leave the entire marked line visible on the piece you intend to keep.
Keep the line, cut beside it.
That's it. Failing to respect the kerf is probably the single biggest reason why beginners find their projects just don't fit together right.
That clicks. That's a huge mental shift.
Yeah.
Respect the kerf.
Okay.
So once you get that, things start fitting better. Now, what about efficiency and making multiple identical parts?
Right. Say you need, 12 identical shelf supports or stretcher rails. You can't possibly measure and mark each one individually and expect them all to be exactly the same. Tiny errors will creep in.
You'll drive yourself crazy.
Totally. That's where a simple but brilliant trick comes in, the stop block.
Okay, what's that?
It's usually just a chunk of scrap wood. You clamp it securely to the fence of your saw. Could be a miter saw, could be a table saw sled at the exact finished length you need.
So you measure once to set the block.
Exactly. You measure super carefully once to position that block. Then you just slide your workpiece up so it bumps gently against the stop block, make the cut, slide the next piece in, cut, repeat.
And because the block physically stops the wood,
Every single piece cut against that block will be absolutely perfectly identical in length. It eliminates all that cumulative error from measuring each piece separately. Super fast, super accurate for repeat cuts.
that's a game changer for batching out parts.
Yeah.
Okay. One more pro trick, especially for machine cuts on things like table saws or rotors, dealing with chip out, that ugly tear out on the exit side of the cut.
Oh, yes, the dreaded chip out. You can prevent almost all of it by using a sacrificial fence.
Sacrificial fence. Sounds dramatic.
It's just a temporary piece of wood, usually MDF or smooth scrap plywood, that you clamp firmly onto your saw's main fence. It sits between the real fence and your workpiece.
Okay, so it covers the main fence. What does it do?
Its job is to provide complete backup support to the wood fibers right where the blade or router bit exits your workpiece.
So the fibers don't break away messily.
Exactly. Wood fibers are weak and prone to tearing when they're unsupported as the cutter leaves the wood. With the sacrificial fence pressed tight against it, the blade exits your good workpiece and cuts harmlessly into the sacrificial piece instead.
Leaving a perfectly clean edge on your actual part.
Bingo! A super clean, smooth edge, essential for good joinery, and just looks much more professional.
Wow. Okay, this has been like a whole toolkit for precision.
Yeah.
Let's recap maybe. We started with Imperial, understanding that 116th is the target, and navigating those fraction and nominal size issues.
Right. Then appreciating the real simplicity and efficiency of metric, especially using millimeters to ditch the fractions.
And crucially, moving beyond just measuring to the art of marking, using those specific tools, the combo square, the gauge, and especially that marking knife for zero width lines.
Understanding how those tools physically interact with the wood to give you a better result.
And finally, the cutting process itself. Respecting the kerf, always cut on the waist side, using stop blocks for identical parts and sacrificial fences for clean edges.
Yeah, putting it all together. What we've really outlined here is that precision. It's not magic. It's not some, innate talent you're born with.
It's the skill.
It's absolutely a skill, a technical skill you build. It comes from understanding these concepts and then practicing them consistently with the right tools and techniques. You're moving from just hoping things fit
Fingers crossed.
to actively engineering the fit. It's a different mindset.
That's the big takeaway, I think. You're equipped now. You have the knowledge to build with real confidence, real accuracy. So what's the immediate next step for you, the listener?
Well, the best way to make all this stuff second nature, to really internalize it so it becomes reflex.
Got to build something.
You got to apply it right away. Find a small, pretty straightforward project, maybe like a simple outdoor planter box or a little step stool or bench.
It's manageable.
Yeah, and maybe use basic 2x4 lumber for it, because that forces you right off the bat to deal with that nominal size issue, the 1.5 by 3.5 reality.
Good point. Puts the learning into practice immediately.
Exactly. You'll have to apply the Kerf Rule carefully. You'll probably want to use a stop block if you have multiple parts the same length. It just cements everything we've talked about. Build that confidence through doing.
Go engineer that perfect fit.
Excellent. Well, that's all the time we have for this deep dive.
Today, we've covered the mindset of precision and seen how tools like a stop block and understanding the 2x4 nominal size issue can completely change your woodworking game. But that's just scratching the surface. To truly turn these insights into real skill, you need a comprehensive guide that brings everything together in one place. That's why I've put together an article, The Ultimate Guide to Woodworking Measuring and Marking. In this guide, you won't just learn how to read a tape measure like a pro. You'll finally master both languages, the intricate fractions of the imperial system and the logical simplicity of metric. I'll show you, with clear visuals and tables, why pros often prefer millimeters, and I'll equip you with the essential tools you need to get started, including my personal recommendations for specific Amazon products you can trust. And most importantly, I'll give you direct access to download 50 professional, free woodworking project plans and a 440-page comprehensive guide to kickstart your first project today. This article isn't just a read, it's your next practical step to becoming the precise woodworker you aspire to be. The link is in the description below. Click it now, stop hoping, and start building with confidence.